Okay, hello, 2342. This is going to be chapter 17-1, part B. We're going to start with esters and do all the other carboxylic acid derivatives, okay? So as we're looking at these carboxylic acid derivatives, we need to state the two different parts of it. So in these esters, we have the carboxylic acid portion of it, and then we have the carboxy portion of it. Or if you can think about it, this would be the carboxylic acid portion of it, and this would be the alcohol you would react with it to make it happen. So if we look at it that way, if we look at our common name here, we would have ethyl group, because we would have ethyl alcohol on this side of it, plus the acetic acid group. And we're going to drop the ic acid and add the word ate or ate to it. So if we look at it as the more common name, as the IUPAC name, we have ethyl ethionate, okay? So this right here, this would be T-butyl alcohol here, and then this would be 1,2,3 propionate. So we have T-butyl propionate, and this right here would be vinyl alcohol or vinyl acetate, since this would be the acetate side, or ethynyl ethionate. So if we were to name these last two compounds here, we would name them for the parent. And so because this is benzoic acid right here, we're going to name that as the common, as the parent right here. So we get the benzoate. And then we have the methyl group at the end here is the alcohol we would use to make it. So we use methyl alcohol to make this benzoate. But then we also have to identify all the other locations. So we have methyl parachloro or 4-chlorobenzoate, okay? So if we have diesters and they're symmetrical, we can say what the two different groups are. And so in this diacid ester right here, we have two ethyl groups, so we can do diethyl malonate, 1, 2, 3, oh my. So this is the oh my part of malonate. So if they were unsymmetrical, you would use them in alphabetical order. So if you had methyl ethyl, you would have ethyl methyl malonate. Okay, oops. And then moving on to our anhydrides here. So our anhydrides are basically just a carboxylic acid that you've removed water from. So that's why they're called anhydrides, or removed water. Okay, and they can be symmetrical or unsymmetrical. If you have the same R groups on both sides, it's easy to replace the acid with just anhydrides. So for example, if we had acetic acid right here, we would just call this acetic anhydride because we had acetic acid that we removed water from, and that's how we would name that as a symmetrical molecule. Okay, so in the systematic name, this would be ethanoic acid right here. So we call that ethanoic anhydride. Okay. So if they're unsymmetrical, we have to do them as the alphabetical name. So this would be 1, 2, this would be ethanoic acid right here, and this would be the malonic acid right here. So we have ethanoic methylonic anhydride, or in the case of this is acetic acid, and then this is formic acid, we would have acetic formic anhydride. So it's just all about doing it in alphabetical order, but with the unsymmetrical ones, it's easier to do that with. Okay, so when we have acyclic acid chlorides, all we have to do is take the ic off the end, ic acid off the end, and add eel chloride. So this was acetic acid, so we turned acetic acid into acetyl chloride, or an ethanoyl chloride right here. So 1, 2, 3 carbons is propionic acid, so it's propanyl chloride. And so if we have benzoic acid, we have benzoyl chloride. And so we can identify that these are the different acid chlorides associated based on their common names. Okay, so the amides have a little bit more complex to them. And so what we think about is how many carbons are bonded to this nitrogen here. So if we only have the carbonyl bonded to the nitrogen, that's one carbon-nitrogen bond, and therefore it's a primary amide. In this case, if we have an R group substituting, taking away one of these hydrogens, then we call that 2 carbons bonded to nitrogen, so that's a secondary amide. And in this case right here, we have 3 carbons bonded to the nitrogen, therefore it's a tertiary amide. Notice that follows along with the idea of amines. 1 carbon to an amine is a primary amine, 2 carbons to an amine is a secondary amine, and 3 carbons to an amine is a tertiary amine. So it follows that nomenclature correctly. Okay, so when we're naming these, we actually can use the common name, drop the oic acid, and add the word amide. So if we have acetic acid here, we go acid amide, okay, or ethanamide. Okay, in this case right here, we have the acetate group with an amide, so we call it acid amide, but we have to show what those 2 groups are here. And we're showing that they're on the nitrogen by putting a capital N and saying, ooh, dimethyl acetamide. So these are both methyl groups on here. So if we had it such that we only had 1 comma, we only need 1 N. So we have an ethyl group here on this nitrogen. And so we have to say N-ethyl for that substituent. We don't care about this hydrogen. It's included in the name acetamide. Now, what if you had an unsymmetrical one here? And you had to name it such that, for example, you had this compound here with nitrogen, an ethyl group, and a methyl group. Well, you have to name both of them, and you name them in alphabetical order. So ethyl comes before methyl, therefore it's N-ethyl, N-methyl. Notice you have to put N in front of each of those to show where those groups are. If you just said ethyl acetamide, it's probably trying to think that you have that ethyl group somewhere else. So the N signifies that these are the constituents on the nitrogen. Okay, the other cool thing about amides is they are also related closely to the nitriles, which we'll talk about later. Okay, so before we talk about that, occasionally we have what we call cyclic esters or cyclic amides. What that means is if the ester functionality actually closes a ring and that ester is within a ring, we actually call those lactones, okay? That's a cyclic ester where the ester is in the ring. And if we have a cyclic amide where the amide is in the ring, we call those lactams, okay? So we're not going to worry about this, but we actually have a weird numbering system. Instead of being 1, 2, 3, 4, you actually start at the alpha carbon or the carbon adjacent to the carbonyl and name it alpha, beta, and then gamma. So this would be gamma lactone. Okay, don't worry about that nomenclature, but I just wanted to introduce the topic of lactones and lactams. Those are cyclic esters and amides, respectively. Okay, so now let's look at nitriles. Nitriles are kind of special because if you think about it, this is just an amide that has to have water removed from it. And because of that, the carbon that had the carbonyl on it is still in part of the name. So imagine we had this amide here, right here, and we took away these 2 hydrogens and this oxygen. So this would be the acetamide because it's 1, 2. It has 2 things here, or ethanamide. So under the systematic name. So that makes this ethane nitrile. So because it's the total of the 2 carbons in the chain and then a nitrile group. This is also called acetonitrile because this was the acetate group. So acetonitrile. So if we have this compound here, we have 1, 2, 3 total carbons right here, and we have a double bond in it. So that would be propene. So the common name would be propene nitrile because we have the double bond. And then we have the common name for it is acrylonitrile. Okay, so let's summarize all the different functional groups we now have for us here. And so when we have acid chlorides, we drop the carboxylic acid and add eel chloride. So we have benzoyl chloride. When we have an anhydride, we take a symmetrical anhydride and do what the groups are named for. This is the benzoic acid, so this is benzoic anhydride. And if it's unsymmetrical, you have to use them in alphabetical order. So if you had benzoic anhydride, we would name it in the alphabetical order. For esters, we have to use 8 for the functional group, but then we have to identify what the remainder, is attached to that oxygen. So in that case, it's the ethyl benzoate. For amides, we drop the echoic acid, and if we have substituents on the nitrogen, we have to signify that they are attached to the nitrogen. So this would be N-methyl benzamide. And if we have nitriles, we just drop it and add nitrile or O-nitrile. So in this case, this would be benzonitrile. So it's from the benzene ring and the nitrile. So benzonitrile. And that is the rest of section 17.1. All right, wait for 17.2.